Hi, my name is Alana Hudson, and I am a part of Challenge 2016. Today we will be answering my Math 1000's first video assignment question. Number 1 asks to explain what it means for a real value function of a real variable to be one-to-one on its domain. Explain the horizontal line test. And how do you find the graph of an inverse function if you know the function of a function, the graph of a function? Explain this and give an example. So first we'll begin with what it means to be one-to-one. If a graph is one-to-one, it means f of x will pass the vertical line test and the horizontal line test. Okay, back again, sorry. So, for a function to be one-to-one, it has to pass the horizontal line test and the vertical line test. So, the horizontal line test is essentially just drawing a line between the function. And it should only touch on one point. Then it would pass the horizontal line test. But it also must pass the vertical line test, which means it only has to touch the function on one point there too. So here are two examples of two functions. We have two graphs. The highlighted is the vertical line test, and the regular green is the horizontal line test. It is very clear that this graph, this function, does not pass the horizontal line test. Why? Because it touches the graph on 2 points. But it does pass the vertical line test because it only touches the graph on 1 point. But for f of x to be one-to-one, it must pass the horizontal and the vertical line test. So does this function pass both? Is it one-to-one? No, it's not, because it doesn't pass both. We have graph B, which is another function, a linear function if you may recognize. And again, the regular green line is the horizontal test, and the highlighted line is the vertical test. The regular green line touches the graph on how many points? Only one. The highlighted line touches the graph on how many points? Only one. So does this pass both tests? Yes. Is it one-to-one? Yes. So that is how you find out if a function is one-to-one visually. But how do you do it when you're trying to solve with an actual equation? So, with an actual equation, if you're trying to find out if f of x is one-to-one, you work it like this. If f of a equals f of b, then it implies that a equals b, then the f of x, or whatever function you have, is one-to-one. So we will work an example. The question here is if g of x, which is 3x minus 2, is one-to-one. So, like it says, we make g of a equal to g of b. You substitute the a wherever you see an x on the left side and a b wherever you see the x on the right side, and you make them equal to each other. So it will read 3a minus 2 equals 3b minus 2. I'll say that again just in case I said it wrong. 3a minus 2 equals 3b minus 2. Now you solve. 3a equals b once you take the negative 2's away, and when you take the 3's away, a equals b. So, does g of a equal g of b? Yes. So, this function g of x, which was 3x minus 2, is 1 to 1. Now we will be moving on to how to find the inverse of a function. How to find the inverse of f of x when you're giving f of x. Please don't mind this work. I have things everywhere, but I will try to explain. In this example, we are giving f of x equals 1 over x plus 1 minus 3. And we are looking for the inverse. So this is what we're giving. F of x equals 1 over x plus 1 minus 3. And we're trying to find inverse. So the first thing you do is you solve the problem, try to get x by itself. So just for purposes for explaining, I did change f of x to y because in any function f of x is y. So you'll just go through how to solve. Minus 3 will be plus 3, and so it'll be y plus 3 equals 1 over x plus 1. Then you'll have 1 over y plus 3 equals x plus 1 when you do the next step of solving for the x. And then, of course, minus 1 on both sides, and you're left with 1 over x plus 3 equals 1. And at the very end, you are then supposed to switch out the x and the y's. So wherever you see a y, you change an x. Wherever you see an x, you substitute a y because they are inverse of each other. The x's and the y's change. So essentially you will go from 1 over y plus 3 equals 1 equals x to 1 over x plus 3 minus 1 equals y. The inverse of f of x equals 1 over x plus 1 minus 3 is 1 over x plus 3 minus 1 equals y. It's another problem down here, but I think we all got the gist of the first one. And it's as simple as that. That is how you find the inverse of f of x.